Hello, this is Dr. Hanaa Assil and this is paper 2CR of June 2019 in the Pearson Edexcel IGCSE chemistry. So let us take a look at the questions and discuss the answers. This is the first question. This question is about gases in the atmosphere. The box gives the names of some gases in the atmosphere. Use gases from the box to answer the questions. Each gas may be used once, more than once, or not at all. The first question is, identify the two noble gases. Of course, if you look at your periodic table, you should realize that the last group on the right, which is group 0, is the noble gases. So we look for which of these are in group 0 in the periodic table. These are argon and helium. Identify the gas that's a compound. You should remember what is an element and what is a compound. An element contains only one type of atom, so it could be in form of individual atoms or molecules in which we have two atoms together, but all of them are the same. That's an element. If we have two or more elements combined together in a fixed ratio, that's a compound. So which of these has two or more elements combined together? That would be carbon dioxide. All the others are elements. Identify the most abundant gas in the atmosphere. You should know the composition of gases in the atmosphere. You should know that air is mostly nitrogen, 78%. We also have oxygen, 21%, and carbon dioxide, 0.04%. Argon is about 0.9%. Identify the greenhouse gas in this list. Remember, greenhouse gases are gases that trap the heat of the sun around the earth, which causes global warming, rise in temperature, melting of the ice. Now, which gases cause that? You should know that carbon dioxide and methane are greenhouse gases. Describe the test for oxygen. What is the test for oxygen gas? Insert a glowing splint. It relights. We said a glowing splint means if I burn the splint and then I close it a little bit, that's glowing. Now when we insert it into oxygen gas, it relights. Question 2 gives the diagram that represents an atom of boron, and we are asked to use the information from the diagram to complete the table. Well, the first thing was asking about atomic number. You should know that atomic number is the number of protons. So from the diagram, we can see that the number of protons is 5. Now, mass number, how do we get mass number? You should know that mass number is the total of protons and neutrons in the nucleus. So, both protons and neutrons are called nucleons. The total number of that is the mass number, and we can see that in this atom, the mass number is 11. Now, how many neutrons? You can see neutrons are indicated and the total number of neutrons are 6. Which group does this atom belong to? Well, how do I know the group? The group is the same as number of electrons in outer shell, so this belongs to group 3. Which period does this element belong to? The period is the number of energy levels. So this is an atom that has 2 energy levels, so it's in period 2. Electronic configuration, that's how we distribute the electrons. Obviously, the electrons distributed in this atom are 2 in the first shell and 3 in the second shell. Boron has 2 isotopes, boron 10 and boron 11, and of course the 10 and the 11 are mass numbers. A sample of boron contains this percent of boron 10 and this percent of boron 11. Calculate the relative atomic mass. How do we calculate the relative atomic mass of an element from its isotopes? We said percentage of one times its mass number plus the percentage abundance of the other times its mass number over 100. This gives a relative atomic mass of 10.8. Crude oil is an important source of organic compounds, and the diagram shows crude oil being separated into different fractions. Name the process used to separate crude oil. We know that crude oil is a mixture of liquids, and to separate a mixture of liquids, this is done by fractional distillation. State what happens to the crude oil at X. Of course, the first thing that we do to the crude oil is when it passes in X, crude oil is heated and vaporized. So it becomes vapors, gases, and it goes up the fractionating column. It is separated according to boiling points. And we're required to describe the difference between fraction B and fraction E. Can you see where B and E are? You should realize that when crude oil is heated and vaporized, it goes into the fractionating tower or the fractionating column. Now, it goes up, all the gases go up, and they are cooled and condensed according to the difference in boiling points. So the one collected at the top, so here for example E is at the top of B. So the one collected at the top have less carbon atoms, that means smaller molecules. They have lower boiling point, lighter color, and less viscosity. They're not viscous. Remember, viscosity means thick liquid. As I go down, it becomes more viscous, larger molecules, higher boiling point. Crude oil often contains sulfur as an impurity. Explain why this is a problem when using crude oil fractions as fuels. Well, if the crude oil contains sulfur as an impurity, then when the crude oil is burned, sulfur is oxidized. So the sulfur burns with the crude oil. It becomes sulfur dioxide gas. The sulfur dioxide gas goes up into the air. It dissolves in the rainwater, causing acid rain. Now, when this acid rain falls, it kills plants, kills marine animals, and dissolves buildings. Remember, acid rain is caused by sulfur dioxide or oxides of nitrogen. Question 4 says, this question is about halogens. The table gives color and physical state of the halogens. Complete the table by predicting the color of astatine and the physical state of fluorine. What is the physical state of fluorine? Remember, fluorine is a yellow gas. Chlorine is a green gas. Bromine is a reddish-brown liquid. Iodine is a dark gray solid. So as we go down, it changes from gas, liquid, solid. And the color gets darker. So it changes from yellow to green to reddish-brown to gray. And the astatine is black. Please be familiar with the states and the color of the halogens in group 7. Chlorine gas is bubbled into a colorless solution of potassium bromide. Explain why the solution turns orange. Remember, in group 7, the one up is more reactive than the one down. So chlorine is more reactive than bromine, and that means if I have potassium bromide solution, and remember that potassium bromide solution is a colorless solution, there is no transition metal, potassium is not a transition metal, so it is colorless. So when chlorine is passed through potassium bromide or bubbled into potassium bromide solution, what happens is chlorine is more reactive than bromine, so it will displace it. So the solution becomes orange because chlorine is more reactive than bromine and displaces it. Potassium bromide is an ionic compound. Draw diagrams to show the outer electrons in a potassium ion and in a bromide ion. So, we look at the periodic table, we'll find that potassium is in group 1. It has 1 electron in its outermost shell. It needs to lose it, so it is left with the inner shell. And here you can either draw the 8 electrons of the inner shell, or you just leave it without any electrons because the outermost electron has been lost. Do not forget to put the positive charge. If an atom loses an electron, it becomes positively charged. Now the bromide, you look at the periodic table and you find that bromine is in group 7. That means it has 7 electrons in its outer shell and it needs 1. So we're going to take the electron that was lost from the potassium, and this would be the electron configuration of the bromide ion. Again, remember bromine here has gained an electron, so now the bromide ion has 1 negative charge. A student sets up a circuit to test the electrical conductivity of water, solid sodium chloride, and aqueous sodium chloride. The table shows the student's results. So obviously, the student found that water alone does not conduct electricity. Sodium chloride as a solid will not conduct electricity, but dissolved in water as an aqueous solution, it does conduct electricity. Explain these results with reference to structure and bonding of the substances. So, let's take a look at water. You should realize that water is a covalent compound with simple molecular structure. So now we have mentioned the structure, and that means when it is a covalent compound, it does not have any free ions or electrons. No free ions, no free electrons, so it does not conduct electricity. Now, what about sodium chloride? You should realize that sodium chloride is ionic. That means as a solid, the ions, and we're talking about ions, ionic compounds, you talk about ions, don't mention electrons. As a solid, the ionic compound has the ions fixed in a giant 3-dimensional crystal lattice. That's the name of that structure. But when in solution, the ions are free to move, so they conduct electricity. A concentrated aqueous solution of sodium chloride is electrolyzed using graphite electrodes. Chlorine is formed at the positive electrode. Give an ionic half equation for the formation of chlorine at the positive electrode. Now, what do we have? We're doing electrolysis of aqueous sodium chloride. That means I have the ions from sodium chloride. I have Na plus and Cl minus. And I also have the ions from water, H plus and OH minus. You should remember all positive ions will go to the cathode, which is negative. All negative ions go to the anode, which is positive. Now, what happens at the anode if we're doing electrolysis of aqueous sodium chloride? This is concentrated. That means we have a choice between chloride and hydroxide. I have concentrated sodium chloride. We said that means it is the chloride that reacts. Now, when the chloride reacts, it gives electrons or it loses electrons and becomes chlorine, and you need to balance the ionic equation. Remember, when we have electrolysis of concentrated sodium chloride, it is the chloride ions which are present in larger amounts. These are the ones that will give up electrons and become chlorine gas. Now, state why this represents an oxidation reaction. Of course, this is oxidation because the chloride ions are losing electrons. So it involves loss of electrons. This is oxidation. Now, what about the negative electrode? Which substance is formed at the negative? Now, at the negative, we have either Na plus or H plus reacting. And we said if we have a choice between Na plus and H plus, it is the one that is lower in reactivity series that reacts. At the cathode, if the choice is between two positive ions, the one that is lower in the reactivity series is the one that reacts. The Na plus is too reactive. Sodium is a reactive metal. It will not want to gain electrons. So the gas that is formed at the cathode is hydrogen gas. Question 5 talks about carboxylic acids, and we're told carboxylic acids react with solutions of carbonates. Of course, these are acids, they react with carbonates. Complete the chemical equation for the reaction of ethanoic acid, and please note how we write the structural formula of ethanoic acid. This is CH3COOH with potassium carbonate. Now, what should we get as products? Of course, we get, this is acid with carbonate, so I should have salt plus carbon dioxide plus water. Now, what's the salt? If I have ethanoic acid and it's reacting with potassium something, this is the salt that we get, potassium ethanoate. So we remove that final H of the COOH, we replace it with the metal. Plus what? This is acid plus carbonate, it gives carbon dioxide and water, and of course we need to balance, so we have a 2 in front of the potassium ethanoate. So, acid plus carbonate gives carbon dioxide gas. So, what would you see in this reaction? Of course, if we're doing a reaction that gives out a gas, the observation is bubbles of gas or fizzing or effervescence. All of these are the same. The ester ethyl ethanoate can be prepared by reacting ethanol with ethanoic acid. This is the method for preparation. Mix equal amounts of ethanoic acid and ethanol in a boiling tube. Add a few drops of concentrated sulfuric acid. Remember, to make an ester, we react alcohol with acid. In presence of concentrated sulfuric acid, place the boiling tube in a hot water bath for several minutes. What is the role of the concentrated sulfuric acid? You should know that in this reaction, the concentrated sulfuric acid is a catalyst. So again, remember, to make an ester, it's acid plus alcohol. Catalyst is concentrated sulfuric acid. So just why the mixture is heated in a water bath rather than directly with a Bunsen burner flame. Remember, you're heating a mixture that has ethanol. Alcohols are flammable. You don't heat anything that has an alcohol directly on a Bunsen burner flame, or it may catch fire. State how you would know that the ethyl ethanoate has formed. How do we detect the presence of an ester? Remember, esters have a fruity smell. From the nice smell or the fruity smell, you can tell that it is an ester. Another ester, methyl propanoate, can be prepared by reacting methanol with propanoic acid. Now draw the displayed formula of methanol, propanoic acid, and the ester. How do we draw methanol? Remember, meth means one carbon. All means it has an OH. It's an alcohol. So this is how you draw methanol. Now, how do we draw propanoic acid? Prop means how many carbons? 3 carbons. Acid means the last carbon has double bond O, single bond OH, and this is how you draw it as a displayed formula. Please remember, there is a bond between the O and the H. Now we want to draw the ester. How do we draw an ester? We draw the acid first. So that is my propanoic acid. And we draw the alcohol. And then we remove what? We remove OH from the acid and the H from the alcohol. Can you see what I'm doing? And you join directly from the carbon of the C double bond O to the oxygen of the alcohol. So we join directly. This is the ester. This is how we draw an ester. Please learn this. It's very important. Give the name of the other product of this reaction. You should know that if I react an acid with an alcohol, we just said what? We said we're going to remove OH from the acid, H from the alcohol. That means I get the ester plus water. My other product is water. I removed H from alcohol, OH from acid, so I get H2O. Give one use of esters. Remember, we said esters have a fruity smell. So what do we use them for? Either food flavorings or perfumes. Question 6 says, when a bottle of wine is left open for several days, some of the ethanol in the wine turns to ethanoic acid. A scientist uses a titration method to investigate how much ethanoic acid is formed if a bottle of white wine is left open for 1 week. She uses this method. Fill a burette with the white wine, record the reading, add 25 centimeter cubed of sodium hydroxide solution to a conical flask, add a few drops of phenolphthalein indicator to the flask, swirl the flask continuously while adding wine from the burette, add the wine drop by drop near the end point, record the reading at the end point. And the first question is, name the piece of apparatus that would be most suitable for measuring the 25.0 centimeter cubed of sodium hydroxide solution. Remember, when we're doing titration, the exact amount of sodium hydroxide that we place into the flask is placed using a pipette. Suggest why red wine would not be suitable to use for this investigation. We were talking about white wine, but here we're saying we cannot do this for red wine. And you should realize that this is because the color of the wine would not allow the color change of the indicator to be seen clearly. We added an indicator and we're supposed to wait until the color of the indicator changes. If there is red wine, we will not be able to see the color change. State why she swirls the flask continuously. Why are we supposed to swirl the flask while doing the titration? You should realize that this is to mix the contents. You could also say to speed up the reaction. State why she adds the wine drop by drop near the end point. Near the end point, I should add drop by drop from the burette so that we see the color change without passing the end point. I don't want to add too much for my calculations. The diagram shows the burette readings at the start and end of one of the titrations. Use the readings to complete the table, and we are told to give your values to the nearest 0.05. That means I want 2 decimal places. Now, you need to remember to put the correct number in the correct place. So here the table starts, usually it starts with the burette reading at the end. Which one is at the end? At the end is the one on the right. Now, how do I read a burette? Remember, we read it from up to down. So this is 22 point something, not 23 point something. So this is 22 point what? You can see from the burette, this is 22.7, and we need it in 2 decimal places, so you have to say 70. Don't say 0.7 and that's it. Now, at the start, what do you read at the start? This is 2 point something. 2 point what? This is 2.1, and then it is in the middle between 0.1 and 0.2, so this is 2.15. Of course, the volume of the wine would be the difference between this, so this is 20.55. The scientist repeats the titration 4 times. The table shows her results for these 4 titrations. Of course, you know that we don't do the titration only once. We need to repeat it until we reach what? Until we have concordant results. You should know, and we are told here, that concordant results are the ones within 0.2 of each other. So the difference between the readings should not be more than 0.2. So which of these results are concordant? Can you see which ones? We have a result that came out 20.4, 20.1, 20.35, 20.45. The ones that are within 0.2 of each other are these. The difference between them is not more than 0.2. The 20.1 is too far off, so we do not include it. And when we are told to calculate the average, we do not take that into consideration, so we're going to add the 3 that are concordant and divide by 3, so this comes out to 20.40. Another scientist repeats the titration with a different bottle of white wine that has been left open for a week. The equation for the reaction that occurs in this titration is this. The mean volume of wine is 19.5. Remember, the wine is the ethanoic acid. That's what we're talking about. So, concentration of sodium hydroxide is 0.05. Calculate the number of moles of sodium hydroxide in 25 centimeter cube. This is what we started with. How do we calculate number of moles? Concentration times volume. Please do not forget to divide the volume by 1,000. I cannot put it just 25. It has to be 25 divided by 1,000 because the equation works with decimeter cubed. That means I have this number of moles of sodium hydroxide. Then the next question says, what is the number of moles of the acid? Of course, I go back to the equation. I look at the relationship between the number of moles of ethanoic and number of moles of sodium hydroxide, I find that they are the same. So number of moles of the acid is the same as what we calculated. Now calculate the concentration of the acid. What is concentration? How do we get that? Number of moles over volume. We are told that the volume of the wine is 19.5. Again, I have to divide by 1,000, and this gives me the concentration of the acid in mole per decimeter cubed. Hydrogen gas can be produced by reacting a mixture of methane and steam in the presence of a nickel catalyst. The reaction conditions are temperature of 700 degrees Celsius and a pressure of 5 atmospheres. And the equation for the reaction is given. First, what does this symbol represent? Remember, this symbol indicates that the reaction is reversible reaction. Then the question says the mixture of methane and steam is heated to a temperature greater than 700. So we're going to increase the temperature. Predict the effect of this change on the yield of hydrogen at equilibrium. Again, remember, the rule is if we increase temperature, the reaction goes to the side that is endothermic. Increasing the temperature goes endo. So if I increase the temperature in this reaction, will it go forward or backward? You can see that the delta H is plus 206. That means that the forward reaction is endothermic, and that means if I increase the temperature, this reaction goes forward. And that means it will go to the right, or the equilibrium shifts to the right, or the reaction goes forward, and that means it will make more hydrogen, so the yield of hydrogen increases. Remember, the question says predict the effect and give a reason. So we are saying, first of all, what are they doing? They're increasing temperature. I should know that always increasing temperature, reaction goes to the endothermic side. Which one here is endo? The forward. So that means here, increasing the temperature, the reaction goes forward, or equilibrium shifts to the right, and that means I get more hydrogen, so the yield increases. Remember, yield means the amount of the product. The yield of hydrogen increases. This is because at higher temperature, equilibrium shifts to the right, since the forward reaction is endothermic. What if the mixture of the methane and steam is kept at the same temperature, but the pressure is increased? Now the rule is increasing pressure, the reaction goes to the side with less number of moles. So if I increase the pressure here, will it go forward or backward? Well, going forward will make 1 mole of CO with 3 moles of hydrogen. That means a total of 4 moles. Going back, it will give 2 moles. And that means increasing the pressure here will cause the point of equilibrium to shift to the left or to go back. Going back means my hydrogen will react with CO to give CH4 and water, and that means the hydrogen is used up. So the yield of hydrogen decreases. So remember, at higher pressure, the equilibrium shifts to the side that has less number of moles. In this case, it is backward or to the left. Calculate the volume of hydrogen gas that is produced when 10 tons of methane gas completely react with steam. So, we have 10 tons of methane. What is the volume of hydrogen? Of course, the first thing we do is get the number of moles of methane. you should know that 1 ton is 10 to the power 6. So, number of moles of methane, we know that I have mass, so I need mass over molecular mass. 10 tons is 10 times 10 to the power 6 grams. Divided by the MR of methane, of course carbon is 12 plus 4, that is 16. Remember, MR means you add the mass numbers, the big numbers. So this gives number of moles of methane. Now, what are we being asked about? They're asking about hydrogen. So I look at the equation. I find that 1 mole of methane will give how many of hydrogen? You can see that they give 3. So that means the number of moles of hydrogen is number of moles of methane times 3. Now we're asked to calculate what? The volume. How do I get volume of a gas? Volume of a gas is number of moles times 24. So the number of moles of hydrogen times 24 gives the volume of hydrogen in decimeter cubed. Are we following? Okay, that was the end of that paper. Thank you for listening. I hope this was useful, and good luck on your exams.